Okay, very good. Let's begin. Today we're going to do the quotient rule. We use the quotient rule when we're dividing one function by another. I'm going to say something really radical here, and I'm going to say there's no difference between multiplying and dividing, that they are the same operation. And let me show you why this is true, right? If we have u divided by v, one way we could express this is u times v to the minus 1, right? We could bring the v to the top. And so you can see, multiplying and dividing are the same operation. So you could go ahead and use the product rule to differentiate that, right? That being said, the quotient rule is for when we're dividing one function by another. It's going to be very clear. We've got u on top of v. Whatever's at the top is the first function. Whatever's at the bottom is going to be the second function. Let's get straight into it. So we're going to identify the top, the numerator. U is the square root of x. Take 5x. Now straight away I'm expressing it in a form that is ready for me to differentiate. Okay, so that's u, and then v is whatever you have as the denominator. All right, we can write u dash. And we can write v dash. And then we're just going to smash it together according to this rule. Has to be u dash v first because you're taking away, you're subtracting uv dash. So u dash v. So that's going to be let's write f dash of x equals half x to the minus half take 5 u dash v. Okay, now I've put them both in brackets. Definitely the first one has to be in brackets because it's got more than one term and you're multiplying them together. If I didn't have brackets, all right, it's just applying to that one, isn't it? So we absolutely must have brackets. In fact, it's very safe to just go put everything in brackets. U dash v, take away. All right, that's the difference from the product rule. The product rule is plus. Take away u v dash. Okay, all of that on top of v squared. So v is 4x, so all on top of v squared. So I've got everything in brackets. Beware here at the bottom as well, like some people just go, oh, the denominator's squared, and they would just write it like that. That would be incorrect because here in brackets, that squared applies to both the 4 and the x. Technically it evaluates to 16x squared. So here, full marks without simplifying. The only time you do need to simplify is when it says, show that the answer is this. Okay, we'll get into the next one. And again, so whatever's at the top, that's going to be our u. Whatever's at the bottom, that's going to be our v. And straight away, I'm going to express it in a form ready for us to differentiate. So x to the 5, take 3x plus 2 to the power of a half. I'm expressing it as a composite function. So we're going to need to use the chain rule there. U dash is just going to be 3. And then when we look at v dash, we have the function to the power of n. So the derivative is going to be n times the function to the power of n take 1. So half take away 1 minus half. And then multiplied by the derivative of the inside here. 5x to the 4, take 3. N f of x, n take 1, times f dash of x, okay? And then you just smash it all together according to this formula. So f dash of x is u dash v take away u dash v, take away u v dash. All on top of v squared. So at the bottom there, I have simplified it, right? I've said it's going to take me more time to put the square root and then the squared symbol outside of it. I'm just going to write it exactly like that. So I've simplified the bottom, but I've left the top as it is. I mean, that's just intuitive. Full marks there, done, okay? When it says differentiate without simplifying, it means, look, you can simplify it if you want, but you're not required to in order to get the marks. So that's the quotient rule. That's all we're going to be doing today. I'll come around and see how we went with the product rule, see if there's any tricky ones, and maybe we might go over a few together. Any questions about quotient rule? Very good.